Good afternoon and welcome to this webinar, Artificial Intelligence, the Next Disruption for Our Industry, and Are You Ready? This event is brought to you by Engineering News Record and sponsored by Kahua. Hi, I'm Scott Seltz, publisher of ENR, and thank you for joining us today. Leading today's discussion, I'd like to welcome Nicholas Johnson, Chief Evangelist at Kahua. Nicholas has served in the design and construction industry for 40 plus years. Starting his career as an electrical designer and drafter, he was among the first to create a career around CAD/CAM technology. When working in IT for Atlanta-based Hiri International, Nicholas learned about construction project management software and startup company Constructware before they were acquired by Autodesk. Since then, he's held sales leadership positions at Autodesk, Trimble, Connected Water, Beck Technology, and Trimble eBuilder. We also have a great panel of experts joining Nicholas today, and we'll learn more about them in just a minute. The panel will take questions at the end of the discussion, so don't forget to submit them during the Q&As in the Q&A section of your webinar console. And now I'll hand things over to Nicholas Johnson from Kahua to kick off today's discussion. Nicholas?
Thank you, Scott, and good afternoon, everyone, or good morning to our friends on the West Coast. Kahua is pleased today to present this conversation about how artificial intelligence will change the construction industry. It's a topic of great interest for us at Kahua, but let me begin by telling you just a bit about Kahua, our company, and what we do. Our project management information system is the world's only low-code application platform built specifically for the complexity of the design and construction industry. We offer purpose-built packages for contractors and subcontractors, for program managers and owners of every type. We are the first cloud service in the construction industry to achieve FedRAMP authorization, the gold standard for cloud computing security for our entire suite of solutions. So now let me just pause and let me ask our distinguished panel to introduce themselves. Gentlemen, welcome and thank you for being with us today. Todd, let's start with you. Tell us just a bit about yourself and the company that you work with.
Yeah, Nicholas, thank you, and great to be on the panel today with my colleagues. Todd Johnston, I'm a managing director in Deloitte's Government and Public Services practice. Actually, lead the firm's AI and advanced analytic work in the defense, security, and justice space. I spent just about the last 23, 24 years trying to help clients in the government and in the commercial sector tie their data to decision making.
Rob?
Yeah, thanks, Nicholas. Rob Lance. I'm also a managing director in Deloitte GPS, along with Todd in the defense, security, and justice space. My focus is in our Navy account, so a lot of awesome stuff happening there. And my background, 10 years in the Marine Corps, machine learning education during that time, and I've done that for quite a while now, and founded a startup that eventually exited with Deloitte, which is how I got here, and loving getting to work with folks like you all and Todd on some of our really tough challenges. Over.
Well, thank you, Rob, and thank you for your service to our country. Sid.
Good afternoon, everyone. My name is Sid. I'm the president of OnIndus, a global advisory firm. Our focus is design and construction owners. So we work with them to optimize operations and manage and extend the asset life cycles. At OnIndus, personally, I'm focusing on continuous innovation for better outcomes, and AI and other of my passions. So looking forward to be in this panel today.
And finally, our own Cosmin.
Thank you, Nicholas. My name is Cosmin Tiku. I'm originally from Romania and a recent graduate from Emory University's MBA program in Atlanta, Georgia. By profession and training, I am a data scientist with a philosophy background and have previously worked in consulting and finance, but now I can say that I found my place working in software and certainly my niche in the construction software management space. So I was brought on board to start Kahua's data science initiatives, and at Kahua, I am the owner of the Kahua Analytics product, which is our own in-house analytics platform powered by Power BI that lives inside of the software. And when I'm not taking on a customer-facing role, I am in charge of internal analytics on our customer and our own internal financial health.
All right, thank you, Cosmin, and thank you all for being with us today again. Before we go any further, we want to get a sense of who's in artificial intelligence. So we're going to bring up a poll now and ask each of you to quickly provide an answer. This will be our only poll question. So I'll pause here and let each of you select an answer to the question. How effectively does your organization leverage? We'll just, again, pause 1 minute here and let you fill that out, and then we'll take a look at the results. Again, this just gives the panelists an idea of where our audience is and perhaps gives you a chance to evaluate your own journey. All right, let's take a look at the results here. Well, as you can see, a good spread. And I love the first solution. We've got some cool spreadsheets. That's where a third of us are, and that's okay. This is a journey, and that's what we're here to talk about today. A very small percentage of our audience is using AI to mine data and provide information about their business that they would not otherwise know. So again, really close thirds here with that very narrow slice of folks that are involved really deep and heavily in this. So. All right, very good. Let's set the stage now. I want to use a quote from one of my favorite quotes. It's from a British mathematician. You might have all heard this before. It's become somewhat popular in our industry to quote Clive Humby, who in 2006 said that data is the new oil. And I remember I really liked this quote when I first heard it. And I only scratched the surface of what it meant. When I first heard it, all I heard was data is the new oil. That made sense to me. Data is like oil, and it's a valuable commodity. I got that. But when I heard what Humby said in full context, and his full quote, it meant so much more to me. You see, what he said was, or what he meant was, that data is like oil, and that its value is not in its raw state. It isn't useful at all in its raw state. It needs to be refined, processed, transformed into something useful. Its value lies in its potential. That quote just seemed much more powerful when I really understood what he was trying to get across, and I think it leads perfectly into our conversation today. It's about this information, this data becoming information, and information leading us to better decisions. And I think that's where AI can help. So Cosmin, I'm going to start with you and let you help us get started today by defining our terms. Can you tell us what artificial intelligence is and how is it different from machine learning or advanced analytics?
Certainly. I am glad to bring a little bit of clarity to these terms since they do get thrown around quite a lot. And I think the main thing to mention here is that artificial intelligence is an umbrella term and a concept. This is the way that I like to think about it. It has a lot of broad and specific definitions, and of course the textbook definition of technology being able to emulate or even simulate human thinking and answers. But my favorite way to think about AI is as a means to an end. It is a framework through which, rather than having ourselves answer very specific questions, we build a tool that helps us tackle a broad array of questions. We're not feeding just a handful of small specific answers. We're really taking advantage of something that can answer something very general. This concept is quite hard to grasp, but I think machine learning, on the other hand, is a much more tangible concept. It is a part of artificial intelligence whereby I see it as a toolkit. It's characterized by algorithms and statistics, and it generally refers to the use of statistical methods and mathematics to predict a certain outcome, right? It relies heavily on inputs and outputs, and it is, of course, a very powerful yet incredibly information and data dependent tool. And then the last term, advanced analytics, also stands as an umbrella term that generally spans the areas of descriptive analytics and predictive analytics. So that's charts, graphs, summary tables on one hand, and decision trees, regressions, probabilities on the other. So just to put that all into perspective and how that flows in, AI is the broader framework under which we operate. Machine learning is one of the tangible tools that we use for prediction in order to achieve said AI capabilities, and advanced analytics were in fact, maybe even the predecessor to machine learning and to the whole concept of AI as we know it today.
Excellent. Thank you, Cosmin. That's helpful, especially those last few words you said. As the least technical person on this panel today, it's helpful for me to understand in kind of layman's terms what we're talking about here. So, Todd, I'm going to ask you the next question and kind of pose it this way. It's hard to get through a day without hearing something new about AI. But what are the capabilities that we're talking about here? How should our audience be thinking about the technology in and around artificial intelligence?
Sure. No, it's a great question, Nicholas, and we'll maybe pull a thread from what Cosmin just said, because that's a great layout of AI and machine learning and advanced analytics. I think the thing to maybe add is, you can't change a channel or read an article or look at your newsfeed on the phone without hearing now about generative AI. Let me add one more thread to Cosmin's umbrella, which is deep learning. So all deep learning is machine learning, but not all machine learning is deep learning. When a neural network model is designed with multiple interconnected layers that continuously tune one another in analytics, you have a deep learning solution. It's how self-driving cars, for those of you driving around in a Tesla and sampling out a bit of the future, classify the objects being detected by its sensors. It's being used in automated hearing and speech translation software. It's things like Alexa, things when your phone magically answers you or Siri comes on. And the type of deep learning being done by massive neural nets is generative AI. So generative AIs are systems that can create content from various modalities: text, image, audio, code, voice, video. It's powered by foundational models such as ChatGPT, which obviously we've all heard a lot about. But in the past months, there's actually thousands of models now, and will be more by the week and by the month that will come out. So GPT is generative pre-training transformer. It's part of that training that Cosmin was talking about in machine learning. So, why is that important? Those are massively evolving technologies that literally are changing by the week and month. But it really all comes down to, if you think of a hierarchy, data, and then models being applied to data, trying to drive a different answers or insights to decisions or questions that hopefully are being asked. And then some sort of visualization or output out of that, where the results of an analytic are going to be delivered to someone. So data, models, viz or outputs, be it a report for your enterprise or something around a recommendation or some sort of visualization or classic business intelligence platform to let you see performance and try to improve it.
Excellent, thank you. And it's interesting, you mentioned GPT. I read an article just this morning in GovTech Today about schools allowing that to be used for essays now. Now that has to become part of what we manage in curriculum. That's at a kind of a base level that probably all of us that have had kids can understand. It's going to be a tool we use, just like when we started using a calculator in school. That seemed like it was a bit blasphemous. How are they going to learn to do it themselves? But we can't imagine operating without a calculator now.
But just remember, back to Cosmin's model, it's giving you an answer that is mathematically related or sounds correct, but might not actually be the factually correct answer. So beware.
Any of us that have used chat understand what that means. Yeah. It doesn't give you exactly the answer that you want or that you would expect, perhaps. So be careful. All right, Sid, I'm going to turn to you because your clients are exclusively in the AEC industry. Where do you see AI being used today in our sector?
Yes, you're right, Nicholas. Our clients are mainly owners in the AEC community. We're seeing the different trends. We're definitely on the general contractor side, they have been trying with more estimation models and scheduling models because they traditionally have data for decades that they can deploy ChatGPT or OpenAI terminologies On the owner side, we mainly serve a lot of public institutions, higher education institutions. In the last 10 years, they have been collecting data. So some of the owners who are on the earlier adoption side, they're dabbling into AI. We're looking at the clients who are hospitals. They may not be leveraging AI in construction today, but on the research side, on the improving their operation side, they're definitely using AI. At Onindus and some of our clients, we're doing some pilot projects. If you have some clients who have collected a lot of schedule data, cost data, they have invoicing data for over 5 years records. Some of them are in a structured database, and some of them are in PDF files, but AI can read that. So we're looking to do some pilots, and we're seeing areas. Other areas where we're seeing from an owner's perspective, they have data for schedules, sometimes given by their contractors, sometimes they're tracking their own milestone schedules. The challenge is the data set, but we're looking at how can we use the data set of last 3-4 years, last 5,000 projects they have done, and can we give them predictive analytics using AI? So running those analytics, we're also looking at doing some AI innovation in training and adoption. You know, our industry has been lagging on using technology. Now we have this platform as Kahua and other softwares. We want them to start using them faster and easily, but also reducing their operational cost. So we're also doing some pilots using AI for adoption and training material management, and a lot of that is done by OpenAI in the back end. And first reaction, our clients are looking at very excited to say, okay, I want to do some AI in my projects. And we're continuing to see that more and more clients have data collections using systems like Kahua. That will continue to grow.
Excellent. So it's interesting. The first question that I see coming into the chat box is just about that, taking data from the past and being able to do predictive analytics on it. So you've almost answered a question before we got to the Q&A section. Well done. Cosmin, I'm going to turn back to you because you work with Kahua's clients to combine multiple data sources into a common analytics environment. Tell us a bit about how this can enhance our client's ability. The work that you do would enhance any client's ability to inform their decision making.
Absolutely. I do have a tangible example here, but I would like to start with a more conceptual schema first, because with the advent and widespread adoption of technologies like data warehousing and relational databases and a plethora of raw and unstructured data, comes the opportunity for someone like me, data scientist, to clean and organize data from multiple data sources into a single coherent and analyzable format. I just gave you a sneak peek essentially into the day in the life of a data analyst, engineer, or data scientist. And so by leveraging the concepts of cardinality, leveraging tools like Power BI and analytics platforms, and having a set of broad empirical questions in mind, we start at the core by creating an common analytical data model. This is all governed by what is called a star schema, meaning that my data, let's say in the construction industry, my data on my financials, my actuals, my estimates, my schedules, and my locations is all flowing through a common denominator. Oftentimes my construction projects or my portfolio of assets, for example. And this is what we mean when we say a project-centric data model or an asset-centric approach. This is what is technically meant by that in the background. And onto the tangible matters, as I did promise a tangible piece to this as well. What you're seeing on screen right now is a Power BI dashboard inside of Kahua Analytics, our in-house analytics platform. It is displaying our fund sources, our financial, our project and location data. In this case, we're a public agency in the metropolitan Atlanta, Georgia area. A very classic case for a construction owner. And as the director of this public agency, I would like to have a bird's eye view over all my actuals, my actual bond funding, my main project KPIs, and they all need to be tied together by one common denominator. In this case, I'm looking at my schools and educational facilities across the metropolitan Atlanta area and across a couple of zip codes. All this data is being pulled from multiple sources with much different levels of granularity. And a big part of pulling all of this data into this dashboard is leveling it all out, working with summaries and putting enough filters in place to slice and dice the data to navigate between those filters and those levels of abstraction. So in this case, with a location-based approach, it means that my data model is tied by my properties, first at a zip code level and then at an actual location level. Nicholas has just clicked on a single zip code and it went into the properties. This meant that he drilled into a single zip code to show all the properties and the rest of the dashboard all contextually filtered to show project, financials, and funds all related to the zip code. So in a nutshell, through the use of a common analytics environment, which runs and is deeply ingrained in this relational data model that we're building, this project-centric, location or asset-centric data model, I'm able to summarize, go up a level of abstraction, or drill into my data at every single level in the hierarchy and at every level of granularity. So I can have a single dashboard to report across the decision-making hierarchy, from the highest agency stakeholders to the individual project owners.
All right, thank you. That's a powerful answer and good examples. Rob, I'm going to turn to you and ask, again, Deloitte has an incredible array of clients. Cosmin has talked about the day in the life of a data scientist. Your clients may or may not have a data scientist on board. They might be asking you to play that role. They might have a team of data scientists. But generally, how does a firm, an organization, one of your clients get started using these kind of capabilities? What should our listeners be thinking about when they are approaching an effort or an investment in their enterprise and using AI?
Yeah, that's a great question, Nicholas. Thanks. So, there's a handful of things to start with. I would say start with the end in mind, right? What is the business or mission problem that you're trying to solve? And that's gonna allow you to make really good choices and maybe trade-offs if you have resource constraints about what's possible and what risks you're willing to take and how you're going to develop something. First and foremost, the foundation of these things is data. My personal expertise or background is in machine learning operations, which has really three pillars. It's data, model development, and model deployment. And that data piece, if you don't get that right, everything else will fall apart. So, figure out, does the data that you have have the answers in it or signal toward the answer that you need? If it doesn't, can you collect that data? If it does, what kind of system is it currently stored in? Is it a legacy relational system that you're going to have to extract and then load into something that's more suited to an analytical development project? Or does it already exist in a warehouse that would allow for the data scientists to get access and all that stuff? Figure out the access bottlenecks for that data as well. Oftentimes, a team of data scientists has all the tools that they need. They're trained, they're skilled, they know the domain, but then they spend weeks or months waiting on approvals from database administrators or that sort of thing, because that stuff typically is restricted for good reason, but the systems and the process aren't built for data science use cases. And so take that stuff into consideration, find those bottlenecks, and then find ways to overcome them so that the teams can get access to that data and store it in a way that makes sense for those analytical workloads. I would say also, picking the right solution or exploring the right areas. If you've got a team that's really good, they might want to, junior data scientists might want to go out and try the next hottest, coolest thing. That's fraught with some risk. Sometimes it's good to have somebody a little senior on the team to tap them on the shoulder and say, that's really great, but have we tried the simple thing first? And that's going to reduce some risk and at the very least give you a baseline of performance on whatever that mission problem you're trying to answer is, that baseline of performance, and then try some of the more exotic stuff and see if that gives you the lift that you're looking for. And then the last thing is, I would say, as a business leader or as a mission owner, expectation management, right? This is a scientific endeavor. That means that failure is always an option. And so what you want to avoid is failure in production. In other words, we've got a fully baked solution. We're deploying it against real analytical problems. And all of a sudden it breaks or falls apart. That's not okay. That's not what I'm talking about. But as we're experimenting, as we're figuring out which of those methods is going to work, as we're figuring out what's in the data and how we can build new features and that sort of thing around those questions, what we want to do is allow that team to iterate a little bit. Don't say, hey, why don't you have the answer yet? Instead, allow them to fail some and then come back with a good answer, when they've done that full exploration. Obviously, you want to time box that stuff. You can't let them go forever, but allowing that space for them to learn and figure out what's in the data. So those three things I think are helpful as you're getting started, and lots of great teams out there, lots of folks that have their own process, but it's a pretty well-worn path.
Excellent recommendations. Thank you. That's great advice. And I imagine that's like with so many things, that's the hardest step to take towards using these tools, is that first step. So thanks for that good advice. I'm going to jump in and ask one question that came to us ahead of time. It would be part of our Q&A, but Rob, you mentioned the term data warehouse. Question came to us: what's the difference between a data warehouse and a data lake?
Oh, that's a great question. Okay, so I will avoid spending the whole half hour or however long we have describing the evolution from database to data warehouse to data lake to fabrics and meshes and that sort of thing, and that evolution. So a data warehouse is a system that allows for usually analytical. It was built for the conceptualized around business intelligence, which is kind of descriptive statistics on what has happened in a business environment. But it's typically relational, and it requires an extract, transform, load pipeline from the legacy systems, the legacy transactional systems, into an environment where data scientists or data analysts can access it and play with that data and produce those business intelligence analytics or other things too. Certainly I've built machine learning models on data warehouse storage systems. What was recognized fairly early on is that with the massive volumes of data and the incredible variety of data that a typical business or agency would care about, it's simply not feasible to extract, transform, load, what we call ETL, all that data, because every ETL pipeline you build is another piece of software that you have to maintain. And so that's a bottleneck really for a data warehouse. And so I won't say a data warehouse is certainly often a good solution. I'm not saying it's a bad solution. It's still a very viable and relevant concept for an organization to employ. But a data lake tries to abstract that away and say, look, we're just going to move the data in its raw form or in its native form into a storage solution that allows the data science teams to access it quickly. And then they can do their own massaging of that data. They can do their own, what we would call kind of munging in the old days, getting it into a format that's useful for model building or analytic purposes. They can do that themselves, but we're going to expose it in its rawest form, and that's what a data lake attempts to do.
All right, thank you. That's great. That's helpful. Cosmin, organizing data for analytical workloads is what you do every day, and you're managing and building a team of data scientists. Just to play off of what Rob just answered, his advice on how to get started, would you add anything to what Rob suggested as a way to be prepared for using AI?
I would first like to say that Rob's answer was spot on when it comes to the suggestions, the recommendations, and the flow generally, both of the data science team and of the analytics pipelines. But I would like to just take this moment to stress the importance of data engineering and those exact pipelines that are able to help us create reproducible results and track all of our steps, whether they're query steps, transformations, feature engineering practices, because at its core, we want to know what data we're feeding into our models so that we can best evaluate the quality. And there are many measures, from accuracy to fit of a model to be able to pinpoint at the end what is the cause of this result.
All right, thank you. That's, again, another great answer and helpful. So I'm going to keep the theme here. And Sid, I'm going to turn to you and ask, what is your team doing? Because, again, you no doubt your clients will need help moving gracefully into their new frontier. So how are you preparing your team to be able to help your clients?
Good point. I think we've been last 3 years, we've been doing a lot of Power BI dashboards and analytics, and now this AI wave is going on. Clients are also getting curious. So how can we deploy? How can we pilot this? So, as Rob said a few minutes ago, clearly defined objectives. So from our owners or AC industry perspective, we're looking at some use cases. One use case is estimating. I work with a lot of public sector owners. They have an estimation tool, they have an estimating team, they collect data, they store it in a spreadsheet, and then they move on to the next project. We have value engineering, healthcare. The cost of escalation has gone so fast, and most healthcare projects that I'm advising on, once the design document bids or package are created, the next stage is, let's get the bids. And week 2, this is too expensive. Let's value engineer it. Let's value engineer the scope. There's several areas like that are early adoption use cases that we can apply. And third one, we're looking also at scheduling. Owners may not have all critical path data that they should, but they have something. They have milestones, they have reports from their general contractor, and we can clean that data, put together into a way that AI model can understand. So those are like sample objectives we're advising on owners to start using in our industry. And then the next part is, okay, we have identified an objective. Step 2 is to collect the data. If it's coming in PDF, we'll use different models to do that. If it's coming in a structured database, data collection and management is step 2. We can't jump on something else. AI, hardware, software, depending upon the data set. We can use their different platforms, not Chat GPT. I've seen a lot of chat going on. There's Google Colab. There are different platforms that AWS is offering to start that, have that database, have that technology available from a hardware, software perspective to do a pilot. And then expertise, like in my team, we've hired some data scientists from Georgia Tech as well, who have done this, for education. Like, I'm not a machine learning expert, but definitely understand the industry, definitely understand how we can collect better data to make better impacts. And I'm working with my data scientists to let's run 3 pilots, 1 pilot for scheduling, let's run pilot for, estimating, see what results. Because 3 years ago, I was in a conference when some individual from Google presented an AI model for a fiber optic. So Google has a fiber company. They're doing fiber layouts, and they have collected a lot of P6 data from different vendors. And they say, if you want to go to a new city to install new fiber, based on our last fiber installation schedule, what is that predictability model? They have to train their model, but after 4 weeks of data, they were able to get 95% of accuracy. So those things are accessible. It's not to a far-fetched dream in our industry. And then engage stakeholders. There's an ethics issue, there's a privacy issue. You need somebody knowledgeable who can advise the leaders especially in the government industry, that running a small pilot with a select number of data with full transparency, that is part. And then the end, pilot. Don't go full steam if you haven't done AI before as an owner. Do a small pilot, call it a research and development project, spend 3-4 sprints. Doesn't need to be a year-long project, and implement that. And then if the model is predicting, because we have to train the model, when you start putting those data from scheduled data from past projects, and a human has to validate train the model. Once we feel like, oh, we're 95, 97% accurate, then hand it over to your business users. And you start using the schedule data when you build your next capital plan as a pilot. So we're doing those kind of transactions, but those steps needs to follow in order for them to actually implement AI in AEC industry.
All right, so you've not just talked about the things that you're doing for your team to prepare to help clients, but you've given a lot of advice for what the clients can be doing as well to prepare themselves. And I imagine you're building material around that. You're building collateral around that's helpful for the kind of templates for the next project. But the thing I heard that I thought was most useful was don't try to eat the entire cake in one sitting. Take a slice, make sure you enjoy it. Don't eat so much that it gives you a stomach ache. All right, so that's great, Sid. Thank you. Todd, I'm going to turn to you again. We're obviously talking about capabilities that could truly transform operations and create opportunity for an enterprise. Do you see other challenges that all that we've talked about, both Cosmin, Sid, and Rob have talked about implementing this for a client? You see other challenges that this could bring?
Well, let me focus, Nicholas, on just what the big one that I think each of us has sort of scratched at, and that's the cultural change. The cultural change in your AEC enterprise's operations that's created by the ability to have some of the inputs or outputs we're talking about, and candidly the cultural change that's needed to optimize these new capabilities. And at the risk of making every analytics person on the webinar cringe and bringing up Moneyball, I mean the best example of that is really going back to Michael Lewis's book Moneyball, not the Brad Pitt movie and everything. I mean, there's kids are back to school, but there's still 2 weeks of summer reading. If you need a summary, read the book, because it's really about the cultural change to unleash the kind of things we're talking about. It's 2002. Billy Beane has the smallest player budget in baseball for the Oakland Athletics. Turns to Paul DePodesta, this Harvard economic grad, to do data mining. But it wasn't baseball's big data moment. This wasn't a bunch of advanced analytics applied. This was none of the analytic elements in the Moneyball story were new arrivals in 2002. Detailed data on baseball players had been available since the 1800s. The regression analysis used by the Oakland A's was a 150-year-old technique using sort of 1980s compute power. And applying analytics to baseball wasn't new. Sabermetrics had been around since the late 70s. So what was new in 2002 and what the story's around is that a leader had the courage to use the insights gleaned from those analytics to drive the way they ran the business. And that took courage. It took courage to overcome a lot of reluctance inside the organization to change the approach of the scouts. It went against the conventional wisdom of how to run a successful enterprise in that arena. I mean, it was the success of a leader in understanding the potential of AI and data analytics, the kind of things we're talking about, for the business to do something different, to operate differently, and to change the organization to deliver on that potential. So steal a bumper sticker from the Kellogg School of Management at Northwestern's got a great way of saying it. Data doesn't make decisions, leaders do. So don't outsource that to your analytics folks. Enable them, and then own the change that in the organization that these things are going to allow you to put forward.
So to borrow another cliche, data creates information. Information creates better decisions.
Yep, and you still have to make them. Yep.
And you still have to make them. Very good. All right, Sid, are there additional challenges that you see, based on your client experiences, that construction teams will face using AI?
One thing I think I would add to what Todd was talking about, change management, right? If once we're starting this model, this estimating model works for owners, and then they have to accept the new norm. The whole hope is the pilot goes successful after one or second iteration, and then these organizations got these new tools, new access to technology, and now have to ensure that this becomes a culture. So there is that internal battle, internal change is coming. It's going to be forced upon us. It's maybe a little slow because we're called laggards in the adoption of technology, but that's what's happening in other industries. In finance, if you read the latest McKinsey study of adoption of AI, they're changing their staffing models in terms of where they want to put people on their retail branches. So down the line, we get more efficient. We know we always have more projects. Every owner I talk to, I can't get enough POs out. There is such a backlog. I have enough bidding to do that we just can't hire enough bid officers. These real problems, I feel like AI, if done and executed properly, can enable them to do more with the same number of resources, but it needs to be done carefully. So I see that kind of an internal challenge in front of us.
Excellent. Okay. Well, at this point, we're going to turn to our question and answer. We are blessed with lots of questions that were sent both before the panel started and during the conversation here. So, Rob, I think I want to ask you the first question, but I'm going to open this to everyone. So all my panelists are welcome to jump in on this. But, Rob, I'm going to start with you and ask, what's the biggest misconception about AI?
Oh, wow. Do I have to only just pick one?
Well,
so
maybe
I'll try. So biggest misconception about AI, I think it is it's really twofold. It's either it's going to take over the world and run all of our lives, or it's not going to be applicable at all to anything, and it's just a fad, and it's gonna run its course, and then we're going to go about business as usual. The truth is somewhere in the middle. Human beings will not be replaced by machines anytime soon. But I think we're gonna see the way we work change, and I think that certainly is applicable in the construction industry as well. And so I think it's one of those two mistakes. Too far on the one end of the spectrum or the other is a huge misconception. Maybe not the biggest, but it's a big one.
Excellent. Does anybody else on the panel want to jump in on that? Misconceptions about AI?
You can throw in a quick one, Nicholas, and it was a shout out I wanted to give Sid for his point on piloting earlier when I was talking about cultural changes. I think a misconception is you have to go for a moonshot, and you have to go for a mega project without, to Sid's point earlier on piloting, taking a question or problem or two, some of even that he was just mentioning a second ago, and playing with it, applying a technology, coming out with some results that can help you on the cultural change point, on the performance improvement point, on some things to build advocacy, build acceptance, and sort of push the ball forward a little bit for the organization. It doesn't have to be a moonshot. In fact, statistics show that the moonshot projects more often than not fall flat.
Yep.
All right, excellent.
I want to add one to it. ChatGPT is not AI. So a lot of beginners said, "Oh, ChatGPT, how's my data out there? Everything is being shared." That's not AI. ChatGPT is a version that's publicly accessible for individuals to do it. But when we are looking at doing this pilot model, we're basically connecting to OpenSQL or a Q Cloud server, putting together a Google Fantago servers. It requires a lot more than ChatGPT to build an AI model, and it's internal. Like organizations who are doing AI in the commercial sectors and not using ChatGPT, they're building their own structure, own models, own Python libraries to build that. So I've seen some people ask about, if I use everything in ChatGPT, we're not saying you to use ChatGPT to build model. We're asking you to collect data, then actually have an expert who understands AI, understands this who understands Google Colab tools to build that, recruit them to do that. So that's a big misconception I hear from my owners when I talk to them. So what about my data? So we're not putting your data, putting in ChatGPT. That's not what we're doing.
All right. Excellent. Thank you, Sid. I'm going to stick with you, Sid, and throw the next question to you. And again, we'll open it up to the other panelists. But what do you think that people, or what things, I should say, what things do people need to think about around data security and around privacy?
Yeah, I think AI brings a big privacy thing. So a lot of organizations I'm working on have hired CISOs. Like there's so many organizations in public sector, housing authorities, cities, they never had this title, CISO. And now it's becoming apparent common. So when you define your pilot, you know, don't use open source technology, especially if you're a government agency. Have your own account on AWS, on Google Cloud, and have a security plan, get it reviewed, have a conversation. It doesn't need to be a book of whole program, but you need to say, this is my security parameters. I'm going to use these virtual machines. I'm going to use this data. I'll have these access. So if you take those 5, 6 basic steps for managing security, this is not hard. But once you start deploying it organization wide, then we're talking an enterprise level strategy of security and discussions. And you have to work collaboratively with CIO. Sometimes you even have to educate them. This is what's going to impact, who will have access to it. So pilot, you can do it with limited concession, but when you start deploying it, this becomes a bigger topic of how to use that and how you're treating a model from a bias perspective. That's one of the unknown, people not talking about it, but that's always a concern there.
All right, I'm going to ask the rest of the panel if they want to jump in, but I'm going to add a little another question, which is very well related. Are we giving away our data to others in order to train the algorithms? Anyone want to take that or add on to what Sid answered the previous question about security? Cosmin?
I'd be happy to speak a little bit to that because I think it is a twofold problem here, or less of a problem, more of an opportunity at times. Our data can be inherently private if it contains unique identifiers, things that can point back to its originator, things that can point to opinions, into personal and perhaps very sensitive information. However, it also represents an opportunity if data governance and security are taken seriously with the advent of anonymization, bulk generalizations, and the fact that we're able to remove the personal factor from data and still use very valuable factual data, especially in the AEC industry, without actually exposing any sort of and having privacy concerns or exposing any personal data, is a massive opportunity that is already being practiced by industry leaders. And it is on to every single one of us to direct our data pipelines and our efforts from the most technical standpoint to use anonymization and in practices like indexing to really avoid this loss of or this dispersion of personal information.
All right, excellent, Cosmin. Thank you for that. I'm going to move on to the next question as we've got just a few minutes left. And Cosmin, I'll throw this to you to start with. Does data analysis have capability of distinguishing between good and bad data available from past projects?
That is a great question, and definitely twists your brain a little bit in your perception of what good and bad data is. Your models and your outcomes are only as good as your inputs. I do like to follow the principle, or try to steer away from the principle, of garbage in, garbage out, and like to set up measures in place to gauge what good data is. And gauges can be very empirical in a sense, handling missing values, handling errors, doing the right aggregations at every level of the hierarchy, leveling out the playing field. All of these are really important factors in knowing that you have good data. But at the end of the day, there is no algorithmic way to predict whether your data is better than the next person's. You only have these empirical, small, fact-based measures in place to gauge whether your structure is appropriate for your task at hand.
All right. We've got several questions come in about the use of AI for design, pointing out that we currently use AI in some ways for estimating. And Sid, you mentioned that in one of your answers. How do you all see AI being used in the actual design of projects? How do you see that today? And what do you predict it might look like in the future? And I'll open the panel up for that one.
I would say that I was researching about BIM models. So the first leverage of AI use cases are already like in pilots in different organizations, especially big design firms, because they're building models. They're using a lot of structured data to design their upcoming facilities. And they're using different sets of materials, different set of information. So they're BIM 300, 400, 500 levels. And there are other tools, built by other companies who are enabling those technologies when you build the model. So there are some early adopters happening in the design phase in the modeling techniques, because you are coming from a set of data models you've been running for the last 20 years, and you have that knowledge there. So if you build a new model, and that AI can influence that and can suggest alternative materials or alternate designs. I'm seeing that's at the curve of innovation. There are definitely multiple pilots happening on that stage right now, but that's more happening on the big design firms who have that quality of data in house today.
Todd or Rob, any answer or any addition to that from your client base? Again, the question was, how is AI being used in design, in the architectural design or the planning of a project outside of cost?
Yeah, I can throw out one thought, and Rob, I don't want to cut you off. I'd merge that too with the modeling and simulation capabilities that allow different design and more high performance design to happen. Rob, am I cutting you off though? I'm going to steal your thunder.
Just a little bit, Todd. But guys, I'm used to it. It's okay. Nice. So yeah, some of what Todd's alluding to, actually in the public shipyards, we have critical national assets that were last updated from a physical layout perspective just after World War II. And it really affects our national readiness. And so there's a lot of work being done to use advanced analytical methods to lay those things out smarter. And that's going to involve a lot of military construction, as well as just placement of assets around those yards to minimize the amount of time that technicians and foremen end up moving around a particular project space for that either maintenance or construction of ships. So yes, we're seeing it in those domains, and it's in its nascent stages now, but really already I would say putting a lot of goodness into those efforts. Over.
All right, thank you all. Those are great answers. I'm going to wrap this up now. Now, for our audience, you'll notice that the thank you slide is up, and we are grateful for you. We've still got a few questions to answer, but I wanted to go ahead and put the slide up so that you can see that email addresses are provided for all our panelists, and they welcome you to reach out to them. So we're going to leave that up for a minute as we finish here, just so that you're able to capture that information as you need it. So panelists, this is a question that was not given to you ahead of time, so we're going to get some really good off-the-cuff answers here. I want to ask you this, and we'll start with Cosmin. What is your bold prediction about AI in the AEC industry? Cosmin, if you could just give us a prediction that's 30 seconds, maybe 30 seconds to a minute or less, please.
Absolutely. And disclaimer, though I run the risk of sounding dystopian, I do think that our decision making will be influenced and ultimately governed by algorithms. And just to explain that a little bit, I do foresee AI being present in every corner of the construction process in this case. That means every contract sent out for approval, every daily report submitted, everything will have a predictive factor to it. Our schedules will be pushed back, they'll be altered, they'll be changed without our direct and obvious consent based on the things that we submit and the data that we provide. This is as bold as I would want to take it for the construction industry.
All right, Sid Shah, bold prediction about AI in the construction space.
I think from an owner's perspective, I would say that my owners are spending 10, 20 projects. Some of the owners are having 30 projects, and it's sometimes get hard. And I expecting that in few years that project status reporting will that be all driven by AI. There'll be schedules feed coming in from the side, and there'll be a cost feed from the invoice paper log. So those time they spend 10 hours weekly on managing those 32 projects, that would be reduced to an hour or two, and they can still focus their remaining 20 hours on the field. So that's what I'm hoping to get, that we can give more time back to our industry who's already constrained, and we can save time for them.
Excellent. Thank you. Rob, bold prediction about the future.
Yeah, thanks very much, Nicholas. So my bold prediction, you guys didn't know that Todd and I had a bet going as to who could give the most dated reference, and I'm going to win that bet. He mentioned techniques used from 150 years ago in baseball, and I'm going to go to the early 1700s when the first piston-driven steam engine was introduced. It was actually an application for pumping water out of mines. And the steam engine itself, that version of it, was not taken up broadly in other places very quickly. And the reason was folks couldn't, they saw that application. They said, well, gosh, I don't have a water problem in my mines. Why would I need that steam engine? And what they failed to see was the broader applications. And I say that to actually kind of piggyback on something Sid said, which is, we're not going to be replaced by this technology, at least it's certainly not in the way it comes to us now. But people who are able to use these technologies in a human machine teaming context are going to have a dramatic advantage. And I think that's going to be especially present in the construction domain because you're so time constrained, and the folks, there's more work than we know how to, or we can do. And the training pipeline can't keep up with the demand. And so you need a machine to take over a lot of that cognitive load in a way that's responsible and trustworthy. And I think that's going to be where the applications go. What it's going to take is people to see the steam engine and say, oh, it applies to me in a different way, but the same technology over in another space. Over.
All right. Thanks, Rob. Todd, you've got the last few seconds, and I'm going to ask you the final question that we like to ask at the end of every webinar. In addition to your bold prediction, just a few seconds of that, please, but where should our audience go if they want to learn more? Are there books, websites? What are the resources that you would recommend to people? So, the floor is yours, Todd.
Oh, wow. Well, bold prediction wise. Well, first, actually, thanks, and on behalf of everyone, thanks again for this chance to be on the panel and have this time to share experiences today. Bold prediction wise, I'd actually connect this last question to the first one you asked, Nicholas, on misconception. I think one of the misconceptions, AI concepts and approaches, some of the models have been around a long time. Well, some of them have evolved. There's more compute power, but one of the biggest differences is just the amount of data today versus in years past. I think the people who succeed, the AEC enterprises that are going to succeed, are people who, to refer back to some of the things that have been said on the panel, know and can manage their data, build that mountain of data that they have, and get access to other data to use. And get again data for the questions that they're seeking to solve, or the decisions they're seeking to make. Data is an asset, so own your data, build your data, and manage your data would be the bold prediction. Those are the people who are going to be the winners.
All right, are there resources that you would recommend?
Yeah, other than pointing out some, I'd say pick a few podcasts, read Wired magazine, but the big message for me would be don't stop, because literally by the week, by the month, some of the different air models, techniques, technologies we've been talking about are changing. You can find new examples of how to apply them. You can find new use cases relevant to your part of the AEC, the AEC domain. Just don't stop. Pick your pleasure. Read, find a good podcast, and keep learning.
All right. With that, I'm going to have to cut it off. I'm sorry we can't get everyone an answer, but Audience, you do have contact information, so you can reach out to our panelists to get more resources if they can be of help to you. We thank you so much for being part of this. On behalf of KUHA and our team, we are just grateful for everyone that attended. Scott, I will turn it back over to you. Thanks again.
Thank you. This was a great conversation, gentlemen. Please join me in thanking our panelists, Todd Johnson, Rob Lance, Sid Shaw, Cosmin Tiku, and Nicholas Johnson, as well as our sponsor, KUHA. If you have any additional questions or comments, please don't hesitate to click the Email Us button on your console, and we'll share those with the panelists so they can respond directly to you. If you haven't completed it yet, you will be redirected shortly to a post-event survey. We look forward to hearing from you about how we can make our programs work better for you. Please visit enr.com/webinars for the archive of this presentation to share with your colleagues, as well as information about upcoming events. We hope you found today's presentation to be a good investment of your time. Thanks again for joining us, and have a great day.